Hello, today's lesson we are talking about dilations. So we have some quick definitions to go through and then a few examples, and then you are on your way to work on related homework problems. So what is a dilation? So a dilation is a transformation. So remember, before when we talked about transformations, we talked about rotations, reflections, translations, and guide reflections. Those were all isometries, meaning they kept the same size. Well, a dilation doesn't. So it's a transformation that enlarges or reduces the size of a figure. All right, and so when we have a dilation, we say the image and pre-image are similar. And we're going to define similarity in a future lesson. Just so you know, we'll define that a little bit more formally, but they're similar. So they're going to be the same shape, but just different size. Okay. A dilation has two key pieces. So the first thing we need to know is we need to know the center. So where are we reducing or enlarging around? And the other thing we need to know is we need to know the scale factor. And so how big or how small are we making the image? Okay, so those are the two key pieces we need to know. And then the next thing we're going to talk about real quick is how to draw a dilation. So the first thing we are going to say is that my point, if you look here, so if I have my center is C and the image of C is itself, okay? So the first thing we know is that the image of the center is itself. Okay, if I have another point, let's say R, and I want to find the image of R, what I'm going to do is it is going to be on the ray between the center and my pre-image. Okay, so image of R is R prime. Okay, and R prime is on ray CR, all right? And then the distance between the image and the center is going to be the scale factor times the old distance, okay? So distance between center and image is going to be the scale factor times distance between image and pre-image. Oh, distance between pre-image and center, excuse me. Okay, so if I wanted to put that in a formula, that would look like the C R prime, right? The length from C to R prime is going to equal the scale factor, which we're calling N, times my old distance, okay? So new distance equals scale factor times old distance. Okay, sorry, my notes are going up here a little bit. All right, so if you look, the new distance, which is NCR, is going to be, that's from C to R prime, right? And then CR is from C to R. So I multiply this by the scale factor, and that's how I know how far R prime will be on that ray. All right, we're going to do some examples for this. It'll make a little bit more sense in a minute. Okay, let's talk about enlargements real quick. So an enlargement is when I am making my image bigger. So if I look here, my pre-image is the red or pink. And then my image is the blue. And if I look, what point is not moving? So A is not moving. So my center is going to be at A. All right, so we see that A prime and A are the same. So that's my center. And then from there, what is happening to the distance of the sides? So if I look, for instance, at CD, here I have that the image of CD is 4 and CD itself was 2. So CD equals 2 and C prime D prime equals 4. So then I say, what do I multiply by to get from 2 to 4? I multiply by 2, so my scale factor is 2. All right. And then if we want to look at what we were talking about when we talk about where my image points are in terms of on the rays, I can see that if I make a ray from A to B and extend it, B prime is on that. If I make a ray from A to C and extend it, C prime is on that ray. If I make a ray from A to D, D prime is on that ray. Okay, so that's what we mean by my image is on the ray between the center and the pre-image. Okay, let's look at another example. So, enlargement. So how do we know if it's an enlargement? It's getting larger. And the big piece here is that our scale factors for enlargement are going to be bigger than 1. So my scale factors are greater than 1. Okay, so reductions. What's happening here? If I look, now my center point is actually not on my original pre-image. So my pre-image is the pink. And my image is the blue. And here my center is point C, and it's in the middle. So it's not on my pre-image like we had in the last one. That's okay. And so if I look here, I'm going to go, if I connect G prime in my center, I see that I have the rays like this. Okay, so here are my rays that line up my images and pre-images for each point. Okay, but if I look at this, my pre-image point, let me draw one of them, a little less crowded. So my pre-image is here, it's G, and it gets closer to my center, and G prime is here. So if I am getting sucked into that center, that's going to be what we call a reduction. And so our scale factor here is a 4th. So let's say the distance from C to G was 4. That means I'm going to take a 4th of that, and my distance from C to G prime would be 1. All right. So my scale factor here is a 4th. And our scale factors for reductions, if I could spell reduction, our scale factors are going to be between 0 and 1. All right, let's do some examples. So our first example A says the blue triangle is a dilation image of the red triangle. So the red is our pre-image. The blue is our image. And it says describe the dilation. So when I want to describe a dilation, what I'm talking about here, remember, is those two pieces. I want the center and the scale factor. Okay? So the center should be the easiest thing to identify. So the center is the point that doesn't change, or it's also like if it's in the middle of the image, it's the point where my image is getting sucked into or blown up from. Okay, so here I see that X and X prime are the same. So my center is point X. Okay. Then the next thing it wants to know is it wants to know the scale factor. Okay. So my scale factor is going to be, we're going to use N. My scale factor is N. Now remember, I'm going to look and say my old distance. Well, let's go back to that formula right here. Okay, so new distance is scale factor times old distance. Okay, so my old distance times my scale factor is going to equal the new distance. Here, I'll put it on this side so it looks like it did up above. Okay, so let's look at that. And we have one example where we can look at old distance and new distance. So the old distance, we're going to look at the pre-image. So my old distance, let me do that in yellow, is going to be from the center to the pre-image. So that is going to be 4. And then the new distance is going to be from the center to the image. So that is going to be 12, right? Because I'm going to add that 4 and that 8. So that's 12. And then go ahead, set it equal times N for the scale factor. So then I get 12 equals 4N, divide both sides by 4. I get that my scale factor is 3. Okay, so my center is X and my scale factor is 3. All right, let's try another one. The blue quadrilateral is a dilation image of the red quadrilateral. Describe the dilation. All right, so same kind of idea here. So in this case, I'm going to look at those rays because I don't have any point that stayed the same. But if I connect K and K prime, I know that the ray goes between those. So I know somewhere along the x-axis is going to be my center. And if I look at J and J prime, those go along the y-axis. So I know my center has to be somewhere along the y-axis. And if I look, those meet at 0, 0. Okay, and I can check that 0, 0 works for M and M prime and also for L and L prime. Okay, so my center is at the origin, which is 0, 0. And now I want to figure out that scale factor. So my scale factor, remember, we're going to use this little formula. So my new distance equals my old distance times the scale factor, which I'm just going to call N. Okay, so we can look at any one of the things you want. I might look at J to J prime because that one's pretty simple. So if I look, let's see here. So my old distance is from 0 to J. So my old distance goes from 0 to J, which is 2. My new distance goes from 0 to J prime, which is 1. Okay, and I'm going to divide both sides by 2, and I get that my scale factor is 1/2. Now let's check to see if that works. So we're going to check. Okay, so my new distance from 0 to K prime, K prime, so is 3. Check, so I want new distance, 3. Old distance, 0 to K, is 1, 2, 3, 4, 6 times N, which we said was 1/2, and I get 3 equals 3, so it checks. And so you might be wondering, well, how do I do it if I have points on, not on the X or Y axis? So if I look at that, let's look at that. That's a good question. So let's look at L. So L is at, let's see here, 6, -4. And then my scale factor is 1/2. So then L prime is going to be, since I'm at the origin, my center is at the origin. This works when your center is at the origin. L prime is going to be at 6 times N and -4 times N, which would be 6 times 1/2 and -4 times 1/2, which gives me 3, -2. Let's check. Is that where L prime is? 3, -2. Yes, it is. Check. Okay, so that's how we do it when we have our center at the origin. So our rule, this is something you might want to put in your notes, rule for center at the origin and scale factor n is my points go from xy to n times x, n times y. All right, let me put that in some like curly cues, you know, make it all highlighted and pretty so that you write it down somewhere, you remember it, maybe you highlight it in your notes for yourself. Okay, so we have a rule, okay? And this is when we are centered at the origin and our scale factor is n. All right, let's try 2 more examples. What is the image of the point A, 9, -6, for a dilation centered at the origin with a scale factor of 1/3? Write the rule for this dilation. Oh my goodness, we just did that. All right, so A is at 9, -6. My scale factor is 1/3, and I'm centered at the origin, okay, which is fantastic. So then my rule says multiply each of the coordinates by the scale factor. So 9 times 1/3 is 3, and -6 times 1/3 is -2. So then I get that A prime is at 3, -2, and my rule is going to be, oh my gosh, my coordinates x comma y map to 1/3 x and 1/3 y. Okay, so there's our answer, our point, and our rule. All right, next. Says, draw the image of triangle PGZ for a dilation with center 0, 0 and a scale factor of 2. So since it's 2, which is greater than 1, we're going to be enlarging this. We're making it larger by a factor of 2. So what I like to do is I like to think, okay, so P has a distance from the origin of 2. So if I make that twice as large, now it has a distance of 4. So P prime is here. G has, okay, so here we go. We can say G has coordinates 1, -2. And so G prime, remember my rule is going to be x, y, and then it's going to be 2 times x, 2 times y. So I double the coordinates. So G prime is at 1, -4. So 1, -4. Oh, double coordinates, excuse me, 2, -4. I thought that looked wrong. 2, -4, here we go. So here's G prime. And then my next point is Z, and Z is currently at -1/2. And if I double both of those, then Z prime is going to be at -2, 1. -2, 1. So here's Z prime. Connect my points. So that looks like my triangle got twice as large, and it exploded from the origin. Okay? And those are all of your examples today, so go ahead and work on your homework.